In this video, we'll talk about the distribution of sample means. You'll use an example from Fundamentals of Statistics by Michael Sullivan. Our example is Old Faithful. The most famous geyser in the world, Old Faithful in Yellowstone National Park, has a mean time between eruptions of 85 minutes. If the interval of time between eruptions is normally distributed with standard deviation of 21.25 minutes, answer the following questions. What is the probability that a randomly selected time interval between eruptions is longer than 95 minutes? For a solution, since the time between eruptions is normally distributed, we can use the normal CDF function on our calculator to find the area under the normal curve to the right of 95. On our calculator, we're going to do second distribution. We want the normal CDF, that's number 2. We'll enter our lower bound, which is 95, our upper bound, which is 1, scientific notation 10 to the 99th power, our mean, which is 85, and our standard deviation 21.25. So our probability is 0.32. What's the probability that a random sample of 20 time intervals between eruptions has a mean longer than 95 minutes? The solution, since the population is normal, the sampling distribution of x bar has a mean of mu x bar equals mu, and standard deviation sigma x bar equals sigma over root n. Using our calculator, on our calculators, again, we're going to use our second distribution. We want our cumulative normal, which is normal CDF. We'll put our lower bound, which is 95. Our upper bound, which is 1 times 10 to the 99th. Our mean, which is 85. And our standard deviation for our sample, which is 21.25 divided by root 20. We get a probability of 0.018. What is the probability that a random sample of 30 time intervals between eruptions has a mean between 70 and 90 minutes? Let's look on our calculator. So we're going to use our normal CDF again. Our lower bound is 70. Upper bound is 90. Our mean is 85. Our standard deviation is 21.25 divided by root n, or root 30. So our probability is 0.9012.